Welcome back again. Uh, I want us to do the vertical projectile motion problems. In my previous video, I did do a one problem, and when I rewatched the video, I realized that there are some things that I did not mention. So you can go to the description, you will see the things that I might have missed. So with that being said, let's do this here. Let me see where I can answer. Okay, I think I found my script. So let's read here. It says Tandega throws a net ball vertically upwards with a velocity of 12 meters per second from the ground. Ignore air resistance. So when Tandega, why is it blurry now? Okay, sorry. When Tandega throws this ball here, what happens to the velocity? It will decrease. This ball will go this way, and then it will reach its maximum height where its velocity is 0, and then it will come back to where Tandeka threw it. So what again can we see here? We can see that the time that goes from where she throws it to the maximum height is the same time from maximum height to where she will catch it on its way back. So the first question says calculate the maximum height that the netball will reach from a hand rather. So what is the maximum height from a hand that the ball will reach? We are not talking about the height from the ground to its maximum height. We are talking about the height from a hand to the maximum height there. So how do we calculate that height there? I'm gonna choose upwards as positive. Don't know why the camera is becoming blurry. I'm gonna choose upwards as positive. So let's solve this problem here. What do we know? We know that initial velocity is 12. We know that the final velocity is 0 at its maximum height. We know that gravity is 9.8 downwards. What else do we know? We don't know the change in time. We don't know the we don't know the displacement. So which formula can we use to find the displacement? Of course, we will take a formula that does not have the change in time here. So what is that formula? The formula is this. It's the only one that does not have the change in time. This is plus here times gravity times change in displacement. Let's substitute in what we know. We know that the final velocity at its maximum height is 0. You know that the initial velocity is 12 because I chose upwards as positive and the ball is going upwards. So plus 2. Here is where you have to be careful. I choose upwards as positive, but gravity acts downwards. So I'm going to put negative here. Negative 9.8. We are looking for change in y. So this is 12 squared. This is the common mistakes that most people do. They forget to square this here. How do we continue from here? We're going to take 12 squared to the other side. 12 squared is 144. It's positive 144. So positive 144 to the other side will become minus 144 is equals to 2 times minus 9.8. It's minus 19.6. Minus 19.6. Change in y. So we can divide both sides by minus 19.6. Let's see here. It's minus 144 over minus 19.6. I get a value of 7,35. I'm going to convert it. So 7,35 meter. And what is this height here? Is the height from here, from Tandega's hand to its maximum height there, because it will reach a maximum height and then come back to where it was thrown. So the height between Tandega's hand and the maximum height of the ball is 7,35 meters. And let's see another question. I hope that was clear. They say calculate the time of the entire motion of the netball if she manages to catch the netball on its way back. So how do we calculate this here? We know that if it takes 2 seconds to reach its maximum height, then it will take 2 seconds to return to where it was thrown, and the total entire motion will be 2 seconds plus 2 seconds, which will give us 4 seconds. So let's calculate the time it takes to reach the maximum height, and then double that answer there to get the total time for entire motion. So I'm not gonna do it here. So which formula we're gonna use? Because we have 4 variables, you can use any formula that have the change in time. So I'm gonna use the first formula there, the one that says Vf is equals to Vi plus G change in t, and I'm gonna substitute whatever we know. So we know that the final velocity is 0, the initial velocity is positive 12 plus gravity acts downwards and we choose upwards positive, so it's minus 9.8 times change in time. So positive 12 to the other side would become negative 12. It's equals to negative 9.8 change in t. So change in t is equals to 12 divided by 9.8. It becomes 1,22 seconds there. 1,22 seconds. So are we done there? No, we are not done, because this is the time it takes the ball to reach the maximum height. It takes 1.22 seconds to reach maximum height. It takes 1.22 seconds to come back. So what is the total time for the entire motion? Of course, it's 1.22 plus 1.22 seconds is equals to 2.44 seconds. So this is the total time for the entire motion. And yeah, that's it for this video here. And for you to be safe, just choose where the ball is going, where the projectile is going, as positive direction. In that way you will be more safe. So let's conclude this video, because these are the 2 common questions that they might ask. So I will see you in the next video.